And then some of it gets over-alkylated to the quaternary tetramethylamine bromide compound, which is what we see here, because nitrogen can grab up to 4 compounds. And that gives you a quaternary ammonium salt. And again, we end up with tetramethylammonium bromide. Reduction of amides. This requires lithium aluminum hydride. Sodium borohydride will not do this. Only lithium aluminum hydride is strong enough, and you really reduce the amide all the way down to amine directly. Reduction of nitriles with hydrogen and nickel. You just gain the hydrogens across this triple bond, and we get down to an amine group. Reduction of aromatic nitro compounds. Tin metal with hydrochloric acid reduces a nitrobenzene down to an aniline. So write the structure of an amide and a nitrile that when reduced would form 2-methyl-1-butanamine. Well, our compound, 2-methyl-1-butanamine, is right here. So to work backwards, we need this to be a nitrile group here, or an amide group, because here's our final compound. So again, if we were reducing an amide, we want that double bond there, because the amide is reduced to an amine. And if it was a nitrile, you'd want it right there to form that into an amine group. Alkaline properties of amines. They are weak bases, and they produce OH ions in water. And so ammonia will grab a proton, so when it reacts with water, you get ammonium hydroxide. Methylamine reacts with water, methylammonium hydroxide. An aromatic amine like aniline is less basic, so most amines have a pH of like 11, but aniline is all the way down to 8.8. It's getting closer to neutral because those electrons are actually pulled in to the aromaticity of the group, and they're not free to attack other things. Amines are much more basic than amides, and the body uses this fact to convert toxic ammonia into urea, which you then expel out by peeing it. Formation of ammonium ions. The ions formed in the reaction of amines with water are substituted ammonium ions. And an amine becomes ammonium when it grabs a proton. And all of a sudden the nitrogen has a positive charge, and that is an ammonium ion now. Amines are also a source of positive charges on biological molecules. For example, in dopamine, your body's pH is around 7.4, and again we saw the pH value for an amine was 11, so at a pH of 7 it's going to be protonated. Same with serotonin. At body's pH there's going to be a positive charge there, and that's important for its biological activity. These are two of the most important compounds in the brain. Salt formation. Because amines are weak bases, they react with strong acids to form ammonium salts. And again, here is an amine reacting with hydrogen chloride to form a salt. This is super common in the pharmaceutical industry. You'll see a lot of compounds are actually an amine. Then there's a HCl because they bubble in hydrochloric acid to form the salt. Because the amine compound is typically a fishy liquid or gas, whereas the salt is typically a white crystalline solid, much easier to compound into a tablet and much more pleasant for people to be around and take. And so this is an extremely common reaction that occurs in the pharmaceutical industry. Many amines or amino compounds are more stable in the form of this hydrochloride salt, so it lasts a lot longer too. When the free amine is wanted, you use a base to free and liberate the amine back. Formation of amides. We can attack an acyl chloride with an amine group to form an amide. And then you could use lithium aluminum hydride to reduce that amide back to an amine. And this is a nice way to controllably make an amine that you purposely want to make. And so this is done a lot. If you just start with an amide, you can remove one of the protons on nitrogen and add an alkyl group, then add another alkyl group, and then reduce the amide to an amine, and you have a tertiary group, or a secondary. If you stopped after 2 steps, that's exactly what you wanted to produce. And so that's a good way to synthesize them. So here we'll get N-ethyl propanamide. Nitrogen compounds are found throughout the plant and animal kingdoms, and they're called alkaloids in plants. They have many, many biological effects, and so a lot of times they're looked for as lead compounds for pharmaceuticals because they're so biologically active. Biogenic amines are derived from amino acids and act as neurotransmitters and hormones in animals. So here we see norepinephrine. This is noradrenaline. And it's an important sympathetic nervous system activator. So, biogenic amines that act as hormones can include the fight-or-flight hormone epinephrine. And so here we saw norepinephrine, and now we get epinephrine. Notice the biggest difference here is this methyl group on the nitrogen. The rest of the molecule looks pretty much identical. And here we have histamine. And so this is coming from a tyrosine. Histamine is coming from histidine. And so the body can convert amino acids into useful biogenic amines. Amphetamines. These are designed to mimic the action of biogenic amines and act as stimulants. They are used to treat depression, narcolepsy, and obesity. They're not really used that much anymore. Amphetamines are used for ADHD because, ironically enough, even though it looks like a hyperactive disorder, ADHD is actually a depressed frontal lobe of the brain, and so a small stimulant will cure that problem. And so some cases of attention hyperactive disorders are treated with amphetamines, the ADHDs, but it's not that common. Ritalin's also very similar in that it is a stimulant purposely trying to bring the frontal lobe of the brain up from depressed to normal activity to get rid of the hyperactive side effects. However, amphetamines are extremely addictive and they have the possibility of being abused, so they're not really prescribed unless they're absolutely necessary. And methamphetamine is typically called speed, and the U.S. has had a long-standing problem with methamphetamine addiction, which is pretty debilitating to a person's life. Barbiturates are another class of drugs that are amines. These drugs are sedatives and depress the activity of brain cells, like phenobarbital. Basic compounds, again, that are derived from plants are alkaloids. Nicotine is a common alkaloid. It comes from the tobacco leaf, and it's why people have been using tobacco leaves for hundreds of years. And it actually binds the nicotinic receptors in the body, which, ironically enough, there are human receptors that perfectly bind nicotine and elicit a response. And this is why nicotine has a pharmacological response in people, because it binds a receptor. Caffeine, another alkaloid, and it acts as a stimulant. It comes from coffee beans and tea leaves. Opium alkaloids, opiates, these also bind opiate receptors in the brain. Cocaine, common narcotic alkaloid from the leaves of the coca plant, and this binds receptors in the brain. And one of the important things to remember here is to get biological activity out of a molecule, there already has to be a receptor in the brain or somewhere in the body that can bind it. The nicotinic receptors are not always in the brain, and so that's why nicotine doesn't really have a psychological effect. For example, smoking too many cigarettes isn't the same as getting drunk. It's not the same psychoactive effect, but it does have a lot of physiological effects on people. Whereas cocaine and the opiates are very psychoactive. They can change a person, and they're extremely addictive and extremely destructive, which is why they are very strictly regulated by federal law. And so opiates and cocaine are only allowed to be used in certain medical situations when prescribed by a doctor who has a DEA license to prescribe restricted substances. And that is the end of our chapter on amines.